Notes. Can you see the slides? Can anyone confirm?
Evet, yeah. Görüyoruz ya.
Tamam. So, okay, let me check. We started the recording. Yes, we are recording. So, hello everyone. My name is Mohamed Hedi Elfkir. I'm Microsoft Learn Student Ambassador. And today we're going to be talking about, it's going to be a boot camp. This is the first session of it. It's Introduction to Machine Learning. And today we're going to know, let's say, the main concepts of what machine learning is. And we're going to use Azure Machine Learning Workspace. Okay. So let's see our agenda for the day. At first, we're going to start what's machine learning and what's its applications, types of machine learning, and we're going to mainly focus on supervised learning, if you know that, because usually, in general, the majority of problems in machine learning are supervised learning problems, and there's divided in two classes: classification problems and regression problems, and we're going to talk about that. Then we're going to go about practice section and then Q&A. So technically, the schedule is going to be at first more the theoretical to see the theory behind what machine learning is, and then we're going to go for hands-on project. And I'm going to share with you GitHub repo in our WhatsApp group. So in there you can follow the project. I'm going to share some other materials. Tamam mı? Okay. So what's machine learning? If you go to Wikipedia and ask what machine learning is, it's going to appear like this. Machine learning focuses on applications that learn from experience and improve their decision-making or predictive accuracy over time. Okay, this is like a fancy way of representing what machine learning is. What I like to do is presenting machine learning based on its application. Mesela, you can think, literally, we use machine learning and artificial intelligence in everyday's life. When you're messaging, for example, when you type in a message on WhatsApp and WhatsApp is predicting the next word that you are writing, that's machine learning going up there. When YouTube, for instance, suggests you certain video to watch, there is a machine learning and recommender system, we call it, and that's based on machine learning. So literally we use it everywhere. Now we speak about autonomous driving, yani a car that's driving itself, and there's plenty of application. Fields, for example, medical diagnosis, we use machine learning in the medical field, automatic language translation, for example, Google Translate, etc. So machine learning in generally split it into three based types of problems, usually. Supervised learning, unsupervised learning, and reinforcement learning. In this bootcamp, we're going to mainly focus on supervised learning. We're going to start by supervised learning, and then later on, maybe the fourth section, we're going to start unsupervised learning problems. But today, I want to focus on supervised learning. Okay, so as I mentioned before, it is split into two cases, two main problems: regression problems and classification problem. What's supervised learning? In machine learning and artificial intelligence, supervised learning refers to a class of systems and algorithms that determine a predictive model using data points with known outcomes. As I said, like this is the fancy definition that you're going to find on Google when you type supervised learning. But I'd like to go with example to get you like the idea of what supervised learning is. So think about it. We are trying to build a machine learning model that classify cats versus non-cats. So like the goal is to give an image to the model, and the model would be able to tell us whether that's a cat or not a cat. So at first, in step one, and we call it the training step, we give a bunch of images to the machine learning algorithm. And then what happens is the machine, and you tell it that that's a cat. So the machine learning, what will notice? Will notice certain patterns that they appear more or less in the pictures. Like for instance, the shape of the eyes, the colors, the shape of the ears, etc. So like even as human, when you see a cat, we know that that's a cat. So in the training phase, that will happen. So we provide the data, we call it labeled data, to the machine learning algorithm, and kind of the machine learning algorithm will be able to map the image to the label. And in step 2, what we will do, we're gonna give certain image to the machine learning without telling it that that's a cat or not. And then the machine learning algorithm will be able to tell us, well, this is cat versus, well, this is not cat. These are dogs, as you see here. So mainly that's what supervised learning is. In the training phase, you present data, labeled data, and then, so yeah, that's why it's called supervised learning. Okay. Arkadaşlar sesim iyi mi yani? Am I speaking so fast or anything? If I'm speaking so fast, I can slow it down or anything. Okay, so what?
Belki birazcık daha yavaş olunabilir ya. Ama sesle herhangi bir sorun yok.
Tamam, daha yavaş konuşalım. Şimdiye kadar clear mı?
Evet, gayet temizdi benim için.
Tamam. So I'll try to slow it down. Sorry for that. Okay. As I mentioned before, the supervised learning problems in real life, they are divided into 2 types of problems: classification problems and regression problem. Maybe from examples you will know what classification and regression. Classification, for instance, is image classification, like the example we give right here: cats versus non-cats. For instance, your email, for example, sometimes you got email and automatically it is classified as a spam email. Okay, so you find it in undesirable, I guess. Yes, so you don't find it in the your main mails. It is automatically classified, and that's machine learning algorithm happening behind there. Regression is when we are trying to predict a continuous variable. What is a continuous variable, arkadaşlar? Continuous variable, you can think of it as price, height. Like it's not a class, it's not 0, 1, 2, 3. It's not cat, dog, I don't know, elephant. These are classes. Regression is continuous variable, as I mentioned. Prices, it can be car production, for instance, per year. So yeah, and we're gonna dive into that. So even if you don't get it right now, later on, hopefully you will get it better. So before dive in what's classification and regression and how to build a classification model and regression model, let's see like the end-to-end usually a process of building a model. At first, in real life, you will start by what we call a data acquisition. What's data acquisition? Demek data almak. We can take it from internet. Like and that's what we usually do. We can take it from the internet, from sensors, for example, autonomous car. Like the data we are getting them from sensors, camera, other type of lasers, other type of sensors, surveys. Okay, and then data cleaning arkadaşlar. Demek ki data temizlemek galiba. So we clean the data collected, bring it into the right format, and keep what's relevant. This is important. That's why I want to go and give an example about it. Okay, let's say we are trying to build this model right here, cats versus non-cats. So we're gonna go on the internet. I'm gonna open Bing and let's say image of cats. Let's say we are collecting the data from the internet. We see images right here, and we made like automated that all these images gonna be taken. So we're gonna end up, for instance, by something like, okay, these are all good, look, beautiful cats. But for example, this picture. Well, this is not a cat. This is kind of building status. And we don't want this type of data in our model because it's not real cat. And it doesn't have the same feature as a normal cat is. Like, for example, here there's the eye, there's the color, there's the mustache, etc. But here it is a status. But in our data acquisition stage, we collected this data. So what we go and do is get rid of this data. Okay. So this is what data cleaning is. Go over your data and see what's good data, what a good data is, what a bad data is, and then try to clean your data to bring it all. We're gonna end up just by images of cats. Bu arkadaşlar gerçekten çok önemli. Because if you go and build a model without cleaning your data, more or less, usually you're gonna end up with unexpected results. Tamam, let's go here. Okay, now we collected the data, we cleaned it, we bring it to the right format. What happened next? The data that we have, let's say we have 100 images, we're gonna split them into 2 data sets. And what's the training data and the test data? Training data is the one, so we're gonna take, let's say, 80% of the data and give it to the training, and we're gonna keep 20% in the test. So what happened? We trained the model that we built. Because we train our model on this training data. We don't show this test data to the model while training. Çünkü, as the name is, test data. So in the next stage, okay, here model training and building. In the next stage, after building the model and training it, we take this model and we test our model on the test data that it didn't see while training. Tamam mı? And in the test data, we know they are labeled data, whether they are cats or not cats. Tamam mı? After that, our testing we will have certain results. And based on the results that we're gonna have, if they are good, we're gonna go and deploy the model. And usually they won't be good. They won't be as good. That's why we go back and adjust the model, and like hyperparameter tuning, we can change the architecture of the model that we built, the type of the model, because you will see in the future there's a variety of models, like linear models, k-neighbors models. There's a lot of models. Tamam. Is there any problem? Because there's something that's coming onto WhatsApp. Sorry. You can write me if anything. Okay. Is there any problem?
Yeah.
Okay, I'll assume that there is no problem because there's something on the group happening, WhatsApp. And yeah, what?
Sanırım biraz önce Google'dan bir şeyler göstermişsin. Bunlar gözükmemiş ekran paylaşımında.
Sorry for that. Okay, I'm gonna go back because it's focused on.
Yes.
Okay. Okay, so stop sharing. Share. Okay. Okay, özür dilerim arkadaşlar. So let's go back to the data cleaning phase. As I said, we get the data, and then we trying to bring it to the right format. The example that we gave was we are trying to build a model so that it can differentiate between cats versus non-cats. So we go to the internet here, gözüküyor galiba şimdi, and we get these images of cats, beautiful cats all over the place. Tamam mı arkadaşlar? And we're gonna take them all because usually this process is automated. We're gonna make a robot or anything to do it. Okay, but what happened is in our data we're gonna end up with something like this image. Okay, you can see it, right? Gözüküyor değil mi? Sıkıntı yok.
Evet, gözüküyor.
Tamam. So this image gonna end up in our data set. But as you see right here, it's not real cat, it's status. Well, it doesn't have the same feature as a real cat. They are bigger than a real cat is. The eyes are not the same. There's no mustache, etc. And it's not real cat. So this type of data, we don't want it in our data set. So what we usually do is delete it, get rid of this data. Bu data cleaning arkadaşlar. Tamam, ama bu gerçekten dediğim gibi çok önemli. Because if you go to the training phase with unclean data, usually you're gonna end up with with unpredicted results. Unexpected result. Kötü yani genel olarak. Okay. Here's the example. So now let's go back to the. Okay. So again, we clean the data and then we split it, as I said, into training and testing. We take 80% of it, that's for training, 20% is for testing. So, and we train our model. Our model will only see the 80% of the data that we provided. Okay. Biraz daha yavaş konuşmam gerekiyor. Okay. So we build the model and we train it. We choose what type of architecture we want to go with. And we train our model based on that. Okay. Later on, the unseen data, which is the test data, is used to test how good our model is, because we want to see how would it act on unseen data. Okay. And based on the result of testing, which usually they won't be perfect, we go back and adjust the model parameters. There are certain parameters in the model we can change. We can overall change the architecture of the model. Çünkü arkadaşlar dediğim gibi, there's a lot of types of machine learning models, and we're gonna see the majority of them. And this iterative thing, like you train and you test again until you end up with a good result. And then the end step, your model is ready for production. So you go and deploy the model. Okay, so this is the end-to-end process of machine learning to build machine learning model. Okay, now we're gonna pass to the classification and regression. Okay, before that, I want to give an example in this testing. What do I mean by this? We said if our model have a good results, but the question is, what's a good result? How we quantify a good result? For this, actually, there's no one answer for that. It depends on the task that you are working with, whether it's a regression task, whether it's classification task. So we're gonna go at first with classification, how to quantify what a good classifier is. Before that, look at it this way. We have our trained model. Tamam mı arkadaşlar? We trained the model and now we are testing it. And in this case, it's gonna be dog classifier, yes. So we trained our model to predict dogs. So we have this image of dog and we have its label, of course. So we're gonna give the image to the model and our model will give us a certain result. It can give us, well, that's a dog. In this case, we compare the prediction to our label that we already have in the test data, and if they match, that's a good prediction. That's correct label. That's good prediction. It's correct. The other scenario is the opposite. You give the image, and well, it tells you, well, that's a cat. It's wrong prediction. And there's two other scenarios. The third one, sorry, is when we give an image, let's say, of a cat to the model and tell us, well, that's a dog, and that's a wrong answer. That's wrong prediction. And the fourth one, I guess you can guess it, is when we give it a cat and tell us, well, that's a cat. Okay, and why I'm explaining this? As obvious as it is what we use to quantify how good our model is. And these four types of prediction that I presented, we can present them in this thing called confusion matrix. What a confusion matrix is. So what's the goal of our model? The goal of our model is to predict whether we have a dog or not a dog. Tamam mı arkadaşlar? So the first type of prediction, which is this one, I guess, is when our model predicts a dog and it's actually a dog. This type of prediction is called true positive prediction. And what's true negative? When our model predicts it is not a dog and it's actually not a dog, that's a true negative prediction. Tamam mı arkadaşlar? And what's false positive? Is when we predict that it is not a dog, but actually it is a dog. And we are left with false negative when we predict it's a dog, well, actually it's not a dog. And I want you to keep in mind, arkadaşlar, in our case right here, we are talking about binary classification. It is whether class 1 or class 2. Class 1 in our case is a dog, class 2, it is not a dog. So this confusion matrix, later on, we can generalize it to multi-class, but I don't want to go through that because it might get complicated. But if we get how to do it with binary classification, we can easily generalize to multi-class classification. But here, in our case, we are talking about binary classification. Okay, after presenting this confusion matrix, we're going to go to answer our question, which is how to quantify what a good model is. For this, for classification, we have classification error metrics, which is like the accuracy, the recall, the precision, and F1 score. What classification error metrics? It is the number, because you know machine learning, and is it all about math? Literally all of it is about math and statistics. So we need the number to say, well, that's a good classifier or that's a bad classifier. And these numbers, they come in the form of error metrics. The accuracy is the most obvious and most intuitive one. As you can guess it, accuracy is the number of correct prediction made by the model divided by the total number of predictions. What do I mean by this? For example, if the X test was 100 images and our model correctly predicted 80 images, then we have 0.8 or 80% accuracy. And bu arkadaşlar, these metrics önemli. If you don't understand something about this, you can stop me at any moment and ask. Okay, but well, accuracy doesn't tell us the whole story. Why? It is useful when the target classes are balanced. What do I mean by this? It means that we have 100 images in the test set. If 50% of them are dogs and 50% of them are not dogs, well, accuracy can be a good metric, but it is not good choice with unbalanced classes. And here's an example. Imagine we had 99 images of dogs and just one image of cat. If our model simply predicted dog every time, we would get 99% accuracy. It looks good, but we know that our model literally does nothing. It's linear mapping. Everything is dog for it. So that's why we go to what we call it recall. The recall is another type of error metric, classification error metric. And it quantifies the ability of a model to find all relevant cases within a data set. What's relevant case? The relevant case is the true positive arkadaşlar, because our main goal is to know it's a dog or not. So the relevant case is it's a dog. So the precise definition, the mathematical definition of it, is the number of true positives divided by the number of true positives plus the number of false negatives. That's why I presented what's true positive, false positive, true negative before for this thing. So that's also one thing. We're going to pass to the precision. It's another type of classification error metric. Well, the precision answered the question, what proportion of positive identifications was actually correct? So the precision answered this question, and mathematically speaking, it is defined as the number of true positives divided by the number of true positives plus the number of false positives. Like, I know there's a lot of terminology right here, but with time you're gonna get used to it. It's not, it may be daunting at first, but then you're gonna get used to it. Especially I'm gonna share everything with you arkadaşlar. Okay, and last we have the F1 score. F1 score is just a combination between precision and recall. Tamam mı? So, and we use what we call the harmonic mean to, the F1 score is just the harmonic mean of the precision and the recall. And one question would be why we are using the harmonic mean rather than the normal mean. Well, here's the answer. We use the harmonic mean to punish extreme values. For example, classifier with the precision 1 and recall 0 has a simple average, the normal average precision per recall divided by 2 of 0.5, but F1 score is 0. So yeah. Okay, so we're gonna pass the regression. Şimdiye kadar can you get everything I'm talking about arkadaşlar? Sıkıntı yoksa devam edeceğim. Okay, I'm gonna assume that there is no problem. And we're gonna go to practice everything on a notebook on programming, but I wanted to start it with the theoretical thing behind what machine learning is, how to know what a good model is, because I guess that's the pillar of it. Okay, now we're gonna pass to a regression model. And before like going to here, okay, I'm gonna open one note. I'm gonna share again, not to make the same mistake. Okay, so you are seeing, right? Page right here. Okay. I assume that there's no problem. Sıkıntı varsa arkadaşlar, you can stop me at any moment and ask. Türkçe de olabilir. Okay, so for the regression model, I want to do something like, we want to see the price of a house based on its size. Okay, so we're gonna plot normal graph right here. Sorry for my drawing skills. Okay, in the y-axis, we will have price. Okay, and down we will have size. Okay, this is in square foot, this is in dollar. So let me go. Okay, so, and we're gonna have a plot. Okay, so points like this, this thing. So like house this size gonna be this price. And usually that's you're gonna end up with in real life. Okay. Okay, so we can see that there is kind of a linear trend, you know? Okay, it's not a perfect line because this doesn't usually happen. If that's happened with you, you're extremely lucky, or there is something wrong with your data. What we are trying to do. So we're gonna go with, I would assume that a lot of us know it. We're gonna go with regression. So we're gonna fit a model right here. Okay, and this is literally machine learning model. Well, hypothetically speaking, this machine learning model. So we build the model, and then we are trying to predict. We are trying to predict, so we have a size, house this size, we want to see its price. So we go like this. Okay, here we have the price. This is called the linear model. And we're gonna go through that. So we built our model. As I said in the regression, we want to predict a continuous variable. Okay, I would be going back and forth. So what am I supposed to do? Okay, let me finish right here. Okay, arkadaşlar, so we built our model. Before going back to the slide, I want to present this notion of called residual. What's a residual? Çünkü bu da önemli arkadaşlar. The residual is the distance between the ground truth, the real price of the house, and our prediction. This distance, this is called residual arkadaşlar. So this is a residual. This is a positive residual. This is negative residual, etc. These are residuals. And think about it, just the distance between the prediction and the ground truth. Bu terminoloji arkadaşlar sadece. But we're gonna need it. And if you go and learn by yourself, you will face a lot of terminology. So, okay, let me go back to the slide right now. Okay. So we finished. We have our regression model. It's right here. So we're going to answer the same question for regression. How to know what a good model from a bad model. So we built our model, etc. There is 3 main metrics: regression, error metrics. The first is the mean absolute error, mean squared error, root mean squared error. What's the mean squared error? Before going to the math, okay, we said that these are residuals, right? The mean absolute error is just we take the absolute value of each residual and we sum them, and then we take the average of that. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So we're gonna sum the difference between the ground truth and the prediction. We're gonna take the absolute value of that and then take the average of that. And I didn't want to show that because it sounds a little bit daunting when you see summing and absolute value, etc. And you can ask why we're taking the absolute value, because we take the absolute value to make everything positive. Because as I mentioned before, this is a positive residual, this is a negative residual. So we should take the absolute value because it is the distance. Tamam mı arkadaşlar? Okay, this is the means, okay, mean absolute error. Later on, the mean squared error, which is, again, the residual, we take the square of it, we sum it. Sorry, I missed, it's this one. The other one was the root mean squared error. So, sorry, the residual, we take the square of it, we sum, and then we average. It's like literally the same logic, but here we take the absolute value, here we take the square. The last one, this is my favorite, and I guess everyone's favorite, is the root mean squared error, and it's just the square root of this one. Why I said it's my favorite? Because unlike the root, the mean squared error, it is interpretable. What do I mean by this? The error would be, the unit of the error would be $. Okay. While in the mean squared error, it's gonna be $². In real life, $² has no meaning. What's $2 squared? But in this thing, we literally can say, let's say we're going to end up with $3,000 root mean squared error. So we can say that on average, our predictions are $3,000 far from the ground truth. This is why the root mean squared error is good, because it gives you a meaning, unlike the other two. So right now I'm done with the theoretical. I will go to implement all of this with code arkadaşlar. Şimdiye kadar sıkıntı var mı? Okay. Türkçe de sorabilirsiniz. Okay. I assume there is no problem. And sorry for the chat. Okay. In here, I'm gonna go with, let me open Google. I'm gonna implement this using Azure Notebooks. Okay, before this, Azure is Microsoft platform cloud service. So I'm gonna go to Microsoft Azure, open my portal. And arkadaşlar, öğrenciler için you can open Azure Notebook without credit card, without anything. And you have, I guess, $200 per year, which is like quite good amount of money. You can spend it on Azure Machine Learning. You can do this using your Hacettepe email. Not Hacettepe, maybe you're not from Hacettepe, but your educational email, that the one end with edu.tr. Using that, you can open Azure account without any credit card or anything. Tamam mı? So let's say you created your Azure account. I'm going to use machine learning workspace. So
Hocam ben sadece slide'ı görüyorum ama.
Sorry again for that. Okay. You can see, right?
Evet, şimdi görünüyor.
Okay. So let me go again. Go to Azure portal, Microsoft Azure, and I'm going to go to my portal since I have already account. As I mentioned, all of you can have, and you can have credit on it, $200, I guess. 200 or 150, I'm not sure. Okay, we create a resource, go to machine learning resource. Okay, let me go from scratch. Create resource, machine learning works. Okay, and then we go and create. Here you finish. More for you, it's gonna be, I guess, educational subscription, and you finish right here. The resource group, it is the name of, let's say, your machine learning workspace. The region, because arkadaşlar, technically, when you're using Azure, you're gonna be using a certain service on a certain server all over the globe. So that's why you need to indicate the region. And usually you want to choose the region closest to you to provide faster service. Okay, arkadaşlar. So let's say you go all over this. Let me create a new one, not a big deal. I already have one, right? Okay, I already have one. So you can see storage. Okay, resource group. I'm gonna call it 101. Create new 101. Okay, workspace name. Let's call them AI. Okay, that name is taken. AI 101. That one is not taken. Then you're gonna go review and create. And it's gonna take a few moments to create. But I already did that. I created, okay. And then after it's created, something like this will appear. Okay, now it's deploying. It might take a few moments to create, because it's literally creating something in a server in West Europe. But let me pass through that. So we have our machine learning space, and it's gonna look something like this. Okay, so we created our workspace. We have this. I'm going to go to the notebook that I already uploaded. I uploaded notebook. I created what's Okay, let me go through this. New compute. New compute is you're gonna choose the computing power, like the power of your CPU, your GPU, that you're gonna use for this machine learning task. And since you have $200, you can spend a little bit of them. I went, because I already built one, I went with this one. It's $0.4 the hour. But arkadaşlar, I'm gonna show you another free option, so you can do everything online. But I would recommend this one because literally here you can go from CPU to GPU, and you can optimize, you can choose the computing instance based on your, let's say, problem. Okay. Okay, so we built our compute instance. It's like the power of the virtual machine. We're done with that. We're just gonna go into the notebook. Okay, notebook görebiliyorsunuz değil mi arkadaşlar? Can anyone confirm?
Şu an görüyoruz notu.
Tamam. Okay, so here we're gonna use two, what we call them, toy data sets. Arkadaşlar, scikit-learn bilmiyorsanız, it is the library, kütüphane, used for machine learning. And this scikit-learn provide us with beautiful data sets, like they're for learning usually. The data is clean in there and everything. So, and arkadaşlar, I'm gonna share this with you later on, so you can go and go over it by yourself. So we do our import packages, the packages that we need, pandas, numpy, and I'm gonna use a seaborn for plotting. Arkadaşlar, pandas ve numpy şimdi yapmayacağım ama dediğim gibi repo sizinle paylaşacağım. Orada pandas ve numpy ve cleaning the data birkaç notebook ama ders şeklinde verildi. You can check it from there and ask me any question about pandas. But here I'll be using literally so basic things with pandas and numpy. Pandas is for the data frame, numpy is for linear algebra. We use it usually for linear algebra and with arrays. So we imported our data. Here's import our data. Okay. Just to put you in what we are going to do. Images. Okay. Bu flowers görebiliyorsunuz arkadaşlar, değil mi?
Evet.
Okay. So here what we'll be doing is, okay, let's go to two things. Okay, this one is better. So what we are trying to do in the iris dataset that we brought from scikit-learn is we are trying to predict the type of the flower based on some features. And these features are the sepal, length and width, and the petal, length and width. Petal and sepal, you can think of them as, I don't know, not papers, like these part of the flower. Okay? So technically, we will have two types of iris, and we will try to classify these irises, whether they are class 1 or class 2. Okay, so bunu yapacağız, classification olarak. But then we're going to go with regression, but we'll start with classification. Okay, so data setimiz öyle. As you said, sepal length, sepal width, petal length, petal width, and the target. As you can see, the target is 0 or 1. We can think of the 0 is type 0 and 1 as type 1. Okay. Here arkadaşlar, CNS is seaborn. Seaborn is plotting library. So we can use this to kind of plot points. The seaborn, no, I didn't share seaborn thing, but if it's a problem, I can share seaborn course on the repo. You can just request that from the WhatsApp group. So, and for this thing, we can see that kind of there is class 1. They tend to have the sepal length tend to be bigger than the other one. Tamam mı arkadaşlar? So literally there is class 1 and class 2, and we can see that. Okay, we're gonna use a very beautiful utility of Seaborn is literally we're gonna plot everything as X versus everything as Y. We're gonna end up with a it's called pair plot. CNS is the Seaborn dot pair plot to have this kind of plot, and it's kind of give us very good information. Tamam arkadaşlar. And here I just wanted you to don't focus a lot about the technical behind it, because I'm gonna share this later. Here I just want you to see that literally from the plot we can see that there is big differentiation between class 1 and class 2. Okay. Ve arkadaşlar bugün genel olarak normalde you don't have this beautiful separation in real life when you're dealing with data. Okay. And here, did you remember we talked about classification errors, error metrics? Like scikit-learn provide this metrics that calculate automatically the F1 score, the precision, and we're gonna use that. So if you remember the pipeline that we already built, we said we get the data, we clean the data, and then we split the data. In our case, the data we collected it from scikit-learn. It is a clean, so we don't have to clean it. Now we're gonna go back to split the data, and before splitting the data, we should separate the target, which is like what we want to predict, from the features. These are called the features. These are our X variables, and this is our Y variable. Tamam arkadaşlar, and okay, get this one. Okay, here Y is iris target, X are the features. Okay, and now we're gonna use more or less one of the most common utilities that you will use is called train test split. And what train test split, it just take your X features, your Y features, and it separate them into train data set and test data set. This is the splitting that we talked about. And here, the test size is just the size of your test set. And usually, like with practice, you usually see they take 0.3. 0.3 is 30%. So 30% of our data is going to be taken as a test data. And this will split three things: the X train, the feature used for train; X test, the feature used for test; Y train and Y test. It's like the target used for train, the target used for test. Okay, here we build the model. We're gonna go with something as a model. I chose something called neighbors classifier. Arkadaşlar gelecek hafta zaten neighbor classifier hakkında konuşacağız. Yani what's neighbors classifier? How does it work? But it can be neighbors classifier. It can be linear regression, not linear regression, logistic regression that kind of we will also see later. But for this case, you're going to build your first model. So we import this k-neighbors classifier, and we CLF. CLF stands for classifier. This is the name of variable. You can choose anything. And we instantiate this. So we create here, this step is the step of creating the model. Okay, so let me put kind of separation between here. It's look beautiful. Okay, this is when you build the model. And then you remember after we build the model, we go and train the model using our training data set. And this what this line stands for. So fit, it is just how scikit-learn is built. Think of it as CLF.fit. So we're gonna train the CLF, which is the k-neighbor classifier that we built, using the training data set, which has like the X train and the Y train. Tamam mı arkadaşlar? So we split the data, we trained the model. What comes next is testing the model. Okay, so testing the model, as I mentioned before, there is like this metrics thing from scikit-learn. So from scikit-learn.metrics import classification report. We're going to talk about this later. This is a beautiful thing. Confusion matrix. We talked about it. F1 score, precision score, recall score, and accuracy score. Okay. So after importing this, we're going to make our prediction. We're going to see what our model will predict on our testing set. So we're going to tell the model, well, this is our X features. Give us predictions, just this X features. We didn't show it the Y features because we're using the Y features and compare them to the predictions of the model. Bu arkadaşlar, before sometimes this is like me printing things. And accuracy score, so you give the real value, the ground truth, and the predictions that your model predicted. And the accuracy score will, as I said, calculate the accuracy of the model. Gonna compare the prediction and the Y test. The same, the recall score works the same way. The precision score works the same way. F1 score works the same way. But they were gonna give us certain values. Well, in this case, it's kind of quite impressive. Like our model give us 100% accuracy, 100% recall, 100% precision, 100% F1 score. Usually in real life, if something like this happen, you would be worried because it is difficult to have this perfect score from the first attempt, if I can say so. But why we had this very good score, like perfect scores? This is for two reasons. The first reason is literally you can see there is literally clear separation between both, like there's no overlapping points between both classes. Well, that's reason number one. Reason number two is our like data set in general, it's not big. It is like we have 100 example and this is too small. So like when we take 30%, so we only tested on 30 points and we trained on 70 points. This small data set with this perfect separation with also how k-neighbors work that we're going to talk about next week can explain this perfect scores arkadaşlar. Ama genel olarak dediğim gibi if I have this good scores, I will know that there's a problem with my data. Tamam arkadaşlar. And here the confusion matrix work the same way as you know, true positive, true positive, true negative, false negatives, false positive, false negatives. The one that we talked about in the slide. And I'm going to share both the notebook with you and the slides with you so you can compare. Okay, what's the classification report that I imported here? The classification report is a beautiful tool because instead of calculating the accuracy and the recall and the precision score and the F1 score by yourself, the classification report do everything for you. Like you give it the Y test, the prediction, and it calculates the precision, the recall, the F1 score, and the accuracy. The support is like the number of points used. So here we have 40 points used from class 0, 16 points used from class 1. So that's what support is, like the number of data points used from each class. Tamam mı arkadaşlar? So this is our classification problem. It's binary classification. And we're going to go with regression. It's going to be more or less the same thing. The only different thing is the feature, the type of features, and the metrics that we're going to use, but the process is literally the same. So we load our data here. Here also the Boston dataset, and the Boston dataset we have certain features, and you're going to predict the price of the house based on these features. So this is our continuous variable target is the price. Tamam arkadaşlar, 24, I don't know, I think $1,000, even though I don't think that's a house, $1,000, million, let's say, but I'm not sure what's the unit. So again, we go and we split the data set into target and features. Bu arkadaşlar if you want to know what's like this Boston.trap target axis 1, it is just, we are telling the notebook to just, from all this, from this data set, don't take target, but take everything else, because these are our features. So we split it. Here, we split the same thing, the X, Y, and 0.3%. Again, we're going to use neighbors, but this time we're going to use K-neighbors regressor, which is not the same as K-neighbors classifier. But again, we're going to talk about it next week. We name it reg as a regression model, fit it, and we have our trained model. Okay, so, and then again, scikit-learn again provide us with the metrics, mean squared, mean absolute error, and the root mean squared error we can calculate it manually. So that's why I don't think scikit-learn provide the calculation of root mean squared error. So again, we're going to take the prediction. So more or less, it's the same thing. We are redoing the same thing, just with different features and different model. Prediction, and then we will have our error metrics. The first one is the mean absolute error, mean squared error, and root mean squared error. Well, this is 4, this is 6, this is 40, and this is totally normal because we are literally taking the absolute, the square of each residual. So it's normal for the mean squared error to be the biggest. So yeah, and the smaller it is, the smaller the error is, the better it is. Tamam mı arkadaşlar? So yeah, so and based on this, we can say that on average, our results, our predictions are 6.35 far from the target. And this is quite bad because if we go here, like the range is not big. So like there's 24. Sorry, why it's not working? 24, 36. So they are not that big. So you have 6 as a. So why it's bugging? Okay, so having 6 as an error is quite alarming. So you should go back because you're having quite bad results. So you should go back and tune the model, etc. Arkadaşlar, sunumuz bitti. Let me go back here. Okay, sorry. Stop sharing here. So as a conclusion and way forward, well, machine learning is way simpler than it looks. It is just, as you see, we built machine learning model and in few seconds, if I can say so, like just using the scikit-learn and the beauty of it. So it's way simpler than it looks. It's just math. You don't need to, but the beautiful thing, you don't need to know the math behind machine learning, thanks to the built-in libraries like scikit-learn, for instance, and for deep learning, TensorFlow or PyTorch. Next week, we're gonna dive in 2 neighbors algorithm, the one we used right here. What are they? How they work? How to train good K-neighbors algorithm, and how to tune hyperparameters. And we're gonna start with K-neighbors, but we're gonna because hyperparameter tuning is in all machine learning algorithms. Tamam. Now it's Q&A session. You can feel free to unmute yourself and ask any question. Soru sorabilirsiniz arkadaşlar. Herhangi bir sıkıntı varsa, soru varsa anlatabilirim. And after this, I'm gonna share the GitHub repo I created for this course. So you can go there and look into the Pandas course and the NumPy course and the cleaning data course. Well, they are notebooks, but in their kind of course format. And this is thanks to Microsoft Reactors. This is their work, but I found it really beneficial. That's why I want to share it with you. Yani bu kadar. Arkadaşlar sıkıntı varsa, soru varsa. I remember something. You go to Google. Okay. So here arkadaşlar, as an alternative, even though I don't recommend it, you can go into Google Colab. It is Colab space when you can use your notebooks and create notebooks from, so like file, new notebook. And you can execute your notebook on Google Colab, and it's free of charge. You don't have to pay anything. Or if you, like me, you want to work locally, I would advise you to install the Anaconda distribution. When there is Anaconda distribution, not this one. Okay, individual edition and Anaconda distribution. Let me show you how it looked like. Okay. It's opening. It usually takes a few times, and it's just usually data scientists use a lot Anaconda because it provides you not just with Jupyter notebooks and Jupyter Labs. It provides you with a lot of other cool softwares also. So that's why I would recommend Anaconda distribution, honestly. Okay, take a few times. In the meanwhile, since we finished, if you have any question, any problem, sorabilirsiniz arkadaşlar, çekinmeyin. And yeah, you have any question, feel free to unmute yourself and talk. Meanwhile, Anaconda is opening.
Merhaba, benim bir sorum olacak ama.
Buyurun.
Should I speak in English or can I speak in Turkish?
Nasıl istersen.
Okay. So, biz bu çiçekleri mesela sınıflandırırken daha önceden belirlenmiş bazı uzunlukları, yani birileri o uzunlukları seçmiş ve ölçmüş. Bize
Tamam.
vermişti. Peki biz mesela hani atıyorum çiçek sınıflandırmak istemiyorum da başka bir şey sınıflandırmak istiyorum. O parametreleri, yani bizim yapacağımız ölçümleri seçerken nelere dikkat etmemiz gerekiyor? Ya da hani ne tarz insanlardan yardım alabiliriz? Atıyorum hani.
So, well, just to make sure that I understood the question right. So you asked, while classifying these flowers, we chose certain parameters. Let's say the sepal width, the sepal length, etc. Right? What type of parameters we choose if we want to classify something else? This is your question, right?
Yeah. Yes. Like, daha çok ne tarz şeylere dikkat etmemiz gerekiyor? Hani o parametreleri seçerken neleri göz önünde bulundurmamız gerekiyor? Ya da çok parametre mi daha iyi? Yoksa bir şeyleri mümkün olduğunca az parametreyle mi sınıflandırmalıyız?
Okay. Well, in the real life, how it happens, we say when you have more data, the more data you have, the more parameters you have, it gives you more freedom. What do I mean by this? Because if you have, let's say, 100 parameter, you can, in the data cleaning process, you can choose what type of parameters you are better for this type of classification. But for otherwise, when you ask me what type of parameters, I don't think there is one answer. It depends on the task you're doing. For instance, let's say we are trying to predict whether, from basic parameters, whether a woman is pregnant or not pregnant. I don't know. Like, the logical thing would be to, because it's medical problem, to take medical features. Anlatabiliyor muyum? So like, it depends on the case that you are dealing with. There's no, what you will try to do, nelere dikkat etmemiz gerekiyor, is trying to choose a parameter that you think, it starts with assumption, that you think this parameter will be able to differentiate between class 1 and class 2. Like, this is how we measure the quality of a parameter, if I can say so. Anlatabiliyor muyum hocam?
Evet, evet.
Tamam. Dediğim gibi, like, and sometimes we start, and probably in real life you will notice that sometimes you start with parameters in data sets, and you find that this parameter is not useful because it is equally distributed between class 1 and class 2. So this parameter is useless because it's not differentiated between classes. So like, this is what you should consider while choosing the best parameters. And hocam bir şey de söyleyeceğim. Well, this is, you can do it manually, but there is some techniques used for, not you select the feature, and this process is called feature selection hocam. Maybe you heard it before, or you will hear it maybe the first time. Ama oluyor yani machine learning, in machine learning. There's, when you let your machine learning algorithm choose the best parameters by itself. O da bir şey var. Onu da göreceğiz zaten.
Çok teşekkürler.
You're welcome. Hopefully that answers your question. Okay, so Anaconda opened. Okay, I want to show you how Anaconda looks like. So this is the Anaconda distribution. And usually I always go to Jupyter, and I launch Jupyter. And here you can run the notebook, or you can create your notebook locally. And that's what I usually do. Or I go on platform. Tamam. So, and here we are finishing. So again, is there any questions other than Serhat Hocam's question? Okay. Türkçe'de sorabilirsiniz arkadaşlar. Okay, so I'm gonna assume that there's no questions. So see you next week, I guess. And on the WhatsApp group, I'm gonna share the GitHub repo link. And arkadaşlar, zaten, if you don't know, we have our Discord channel. Oradan da you can ask me about anything. I'm gonna be sharing stuff over there also. Yani, join that Discord channel also. I'm gonna share the link again in the WhatsApp. And yeah, we are done for today, I guess.
Dalmadan ben bir soru daha sorabilir miyim?
Buyurun hocam, tabii ki.
Jupyter'i falan kullanırken Python'ın 3.8'ini mi kullanalım, yoksa hani en optimize sürüm 3.6 mı? Yapay zeka.
I would, well, yapay zeka işlemleri, usually you can use any version, but what I recommend, usually go with the updated version, with the latest version.
Okay.
Because there's all the time there's new features, and you want to keep yourself updated. So I would recommend you to go with the latest one.
Teşekkürler.
You're welcome. Okay, so I guess we have no other questions, arkadaşlar. Okay, I'm finishing the meeting. I guess see you next week. Görüşürüz.
See you.
Görüşürüz. Teşekkürler.
Görüşürüz.
Teşekkürler, görüşürüz.
İyi günler.